Introduction to Backpropagation. Backpropagation, short for backward propagation of errors, is a fundamental algorithm used to train artificial neural networks. It efficiently computes gradients, enabling the network to adjust its weights and biases to minimize prediction errors. How backpropagation works. Forward pass. Input data is passed through the network to generate an output. Loss calculation. The difference between the predicted output and the actual output is measured using a loss function, e.g., mean squared error. Backward pass. The algorithm computes gradients of the loss with respect to each weight by applying the chain rule, propagating the error backward through the network. Weight update. Weights are adjusted in the direction that minimizes the loss, typically using an optimization algorithm like gradient descent. Mathematical foundation. Backpropagation relies on the chain rule from calculus to compute the gradient of the loss function with respect to each weight in the network. This allows for efficient computation of how changes in weights affect the overall error, facilitating effective learning. Key components. Activation functions introduce nonlinearity into the network, enabling it to learn complex patterns, e.g., ReLU. Sigmoid. Loss function quantifies the difference between predicted and actual outputs, e.g., mean squared error. Cross entropy. Learning rate determines the size of weight updates during training, a critical hyperparameter that affects convergence. Advantages. Efficiency enables training of deep neural networks by efficiently computing gradients. Scalability applicable to networks with many layers and parameters. Automation facilitates automated learning from data without manual intervention. Challenges. Vanishing, exploding gradients. In deep networks, gradients can become too small or too large, hindering effective training. Local minima. The algorithm may converge to suboptimal solutions depending on the loss surface. Computational cost. Training large networks can be resource intensive,